Welcome to Heat and Energy Transformations, Cornell Notes with Miss Ungerleider. This is Unit 3. Please put your first and last name on your Cornell Note sheet. Make sure that you fill in your date. Your topic today will be heat and energy transformations. This is a two-part Cornell Notes that we are going to get through 100% before we leave today. Okay, let's go ahead and get started. So the first part of this Cornell note set, we're specifically going to talk about heat. So please put the word heat on the left side of your paper in that main column, because that is going to be one of your keywords. Okay, everything on this slideshow that is in bold will be to your left. In your left-hand column, those are your main ideas. And then the parts that are underlined are going to be your details that will go or be written in your lines. Remember, you don't have to write everything word for word, okay? Eventually, I would like for you to get to the point to where you're able to identify main ideas in what is underlined and just write the main ideas. Okay, so let's start with heat. Heat is transferred energy that comes from the random motion of molecules and is felt as temperature, especially as warmth or hotness. Okay, now I know when you think heat, you think hot. Okay, but actually even cold things have heat. Okay, because those molecules, they are moving at random. Okay, and then the faster the molecules move, the warmer the temperature. So heat is transferred energy. Think about that word transferred. What does transferred mean? Think about it. Okay, if you're thinking that transferred means moved, you are correct. Transferred energy, energy that is moved, that comes from the random motion of molecules and is felt as temperature, especially as warmth or hotness. Okay, and this last part right here, where it says heat is transferred in 3 ways, I want you to put a star by conduction, convection, and radiation. Because those 3 words are huge during this unit. Okay? You have to know what conduction, convection, and radiation are, and you need to know examples. Okay? The success, your success on the unit test will be determined by whether or not you know conduction, convection, and radiation. And please make sure you know that those are the 3 ways that heat moves. Can I move forward? Okay, another big idea. Hot moves to cold. Hot moves to cold. Okay, if anybody asks you how heat moves, you would say that hot moves to cold. And there's evidence of that when you make a cup of coffee. The coffee is hot, but over time, it cools off because hot moves to cold. Okay? You can write that example. You can draw a coffee cup if you would like to help you remember that. Also, say you're boiling some water. You put a metal spoon in the pan. The heat will move up the metal spoon because hot moves to cold. Okay? Another big idea. We talked about heat being the random motion of molecules. Okay? In something that is very, very hot, the molecules move very, very quickly. And you can actually see molecules moving very quickly when you boil water. The water molecules will bump together faster and faster and faster until the water is boiling, and you are literally seeing those molecules boil and bubble over because they're moving so rapidly. And it produces heat. Okay, it's just like when you rub your hands together faster and faster and faster, you're going to produce more and more and more heat. Okay, now the opposite of that is that molecules, they move very slowly in a substance that is cold. Notice it does not say that the molecules stop. Okay? They just move more slowly in a substance that is cold. When you think about water molecules bumping together quickly, I really do want you to think about what happens when you create friction by rubbing your hands together. Okay, the water molecules are actually bumping together very quickly, and it creates more and more heat. May I move forward? Okay, you put a star by this word on one of your previous slides. The word conduction. Okay, and I want you to think about where you have heard that word before. No, not in your music class. Okay, I'm hoping you're thinking more along the lines of things that are good conductors of heat. Okay, so conduction is the transfer of thermal energy through solids or direct contact. Solids or direct contact. So when your hand makes direct contact with a hot surface, that would be an example of conduction. When you place a metal pan, which is already a good conductor of heat, onto a hot stove, that pan is making direct contact. Okay? When you are barefoot and walking on hot concrete, your feet are making direct contact with that hot concrete, and that heat is then being transferred to the bottom of your foot. Okay? So we're talking about the way heat moves, and in this type of heat movement, the heat is moving through direct contact, and we call that conduction. Okay, there is a word here. It says the transfer of thermal energy. That word thermal means heat. Okay, think about thermal underwear. We wear those in the winter to keep us warm. Okay, the word thermal means heat. Okay, may I move forward? Yeah. Before we move forward, I want you to look up here. I want you to look at the diagram, and I want you to identify where conduction is taking place. I know it's already identified it for you, but kind of think of what is going on there. Okay, his hand is making direct contact with the hot handle. Okay, so that's conduction. Okay, the second way that heat moves is through what we call convection. And this is the one that students typically struggle with, okay, because a lot of times people don't see it. They don't know it's happening. It's a little abstract, I guess you could say. So convection is the transfer of thermal energy, remember the word thermal means heat, through fluids. So a fluid could be a liquid or a gas. Okay, and in this specific type of heat transfer, the hot air or water will rise and the cool air or water will sink. And it creates a current. This constant current, this constant movement through either air or water, liquids or gases, where the heat will rise and the cold will sink, and it just keeps along with this current. Okay, convection is what is responsible for our ocean currents. Okay, It's what's responsible for our atmospheric currents that cause weather patterns. Inside of this picture of the pan of water that is being heated, the water at the bottom is hot because of the fire. Okay, and so the hot water will move up, and then that cold water will sink down because it wants to become hot too. So it creates this convection current, and that's actually what heats the water in that pan, is convection. We have, many people have convection ovens, okay, which are highly desirable because they will cook your food evenly. Okay, when you bake cookies, you don't want the front of your pan to be burned and the back pan of your pan to be raw. You want them to be cooked evenly. Same thing with like your meatloaf. Okay, really when you're cooking anything, you want it to be cooked evenly, and that's done through a convection oven. Another example of this would be, most basic level, it's kind of like when you're sitting in a bathtub and you turn the hot water on, and you push the cold water that's behind you forward because you want it to get hot, and you push the hot water that's in front of you behind you because you want to warm your bum, right? So you literally are creating this current inside the bathtub. Okay, so that's how you would be able to see and feel that visually. Okay, think about what slide is next in your head. Think about it. Were you right? Okay. So the third way that heat moves is through radiation. And I want you to think of all the different ways, or all the different, when you have heard this before. Okay, think about that. Radiation. Hopefully, memories of our waves unit are popping up in your brain. Radiation is the transfer of thermal energy. Remember that word thermal means heat, through space via waves. So heat travels in waves via radiation. Okay? We experience radiation every day. Okay? The heat that warms our atmosphere comes from the sun in waves through radiation. I don't know how many of you have ever made sun tea in the summer. You get a plastic jar, you put a few tea bags in it, you place them outside on a sunny day, and the heat or radiation from the sun activates the chemicals inside the tea bags, and they will release the tea. Okay? And then if you wait a bit, you'll have sun tea, which is really good. You're bringing lab supplies for your solar ovens. Okay, hopefully you'll be able to trap enough solar radiation to be able to melt your marshmallow and your chocolate. So most people's chocolate will melt, but it's really difficult to get the marshmallow to melt. And I love doing the solar ovens on a cooler day because I want you to be able to see that even though it's cool outside, you can still trap heat inside of your oven. Okay? UV radiation. That's another example, obviously, of radiation because most radiation comes from the sun. Okay? The bottom picture is a campfire. When you're standing by a campfire, you can feel the heat radiating from the campfire. You do not have to put your hand on the fire to know that it's hot. Okay, so that is radiation. Okay, so that is part one. Okay, let's kind of review what we talked about. Okay, we talked about heat. We talked about the fact that it moves from hot to cold, and that it moves through conduction, convection, and radiation. Okay, so let's go ahead and start the second part, which relates to, okay, but isn't exactly. So you can even put like a little line or a squiggle or something to show that this is part two. Okay? Okay, so during part 2 of your Cornell notes, we are going to discuss the law of conservation of energy. And the law of conservation of energy simply states that energy cannot be created or destroyed. It can only be transferred. Okay, and so at its most basic level, everything can always be transferred from kinetic to potential energy, from kinetic to potential energy, from kinetic to potential energy. Just back and forth, back and forth, back and forth. Okay, this pen, okay, it has potential energy. Say I drop it. When it's actually moving, it has kinetic energy, energy of motion, and then once it's at rest again, it has potential energy. Okay? So energy cannot be created or destroyed. It can only be transferred. Okay, let's look at this bike example from the picture on the slide. Okay, when your bike is in the garage, it has potential energy. It has the potential to do work, but it's not doing work until you actually get on the bike, okay, and start moving the bike. Then you have kinetic energy. Okay, the biker at the top of the hill, okay, that's where the bike would have the most potential energy. Okay, and then as the bike moves down the hill, okay, it increases in speed, its kinetic energy increases. Kinetic and potential. Law of conservation of energy. What we're going to study in this section of Cornell Notes is really how that energy is transferred and what types of energy it is constantly being transferred to. So in this example, it's constantly being transferred between kinetic and potential, kinetic and potential. But there are other types of energies that we're going to learn about. And here they are. Okay, so these are going to be the types of energy that we are going to discuss during this Cornell Note set. Energy cannot be created or destroyed. It is just constantly being transferred between these different types of energy. Remember, kinetic and potential are really your two most basic. You could always throw that out there and find examples of things being constantly transferred between kinetic and potential. But there are some very specific types of energy. So you've got thermal energy, which is heat. You've got chemical energy. You've got electrical energy, mechanical energy, light energy, and sound. Okay, and those are going to be all of the types of energy that we are going to explore. So moving forward, when we are taking notes, okay, I want you to try really hard in this note section to pull out key terms and I don't want you to have to write every single thing that is in the lines. I definitely want you focusing on the examples. The examples that I'm going to give you are going to be examples from your test. So let's move forward. Okay, so make sure you write these two. Kinetic energy, potential energy. For kinetic, you could literally just write motion. And for potential energy, you could write the word stored. Okay, also make sure that you know that there will be times when I write KE for kinetic energy and PE for potential energy. People shorten those. So make sure you have those written down. Okay, take a look at what's going on in the graphic. Identify where the weight has potential energy and where it has kinetic energy. Okay. Thermal energy. The word thermal is heat. So energy that is related to the temperature of a substance. Energy that is related to temperature of a substance. When you rub your hands together, you could say that that is kinetic energy because your hands are moving. Okay? But there is energy transfer going on there. Okay? Because the kinetic energy is moving to thermal energy because your hands get warm. So there is an example of energy transfer. Energy cannot be created or destroyed. It can only be transferred between different forms of energy. Can I move forward? Okay? Next one, chemical energy. Chemical energy is energy that is stored in matter because of the object's chemical makeup. And that chemical energy is released during a chemical reaction, okay, which is something that we will talk about in our next unit. Food has stored chemical energy. Okay, when you eat the food, your body digests it. There's a chemical reaction that takes place. Okay, it releases calories, which is heat. Okay, the gasoline has stored chemical energy because it came from living things that lived millions of years ago. Okay, and then that chemical energy is released when it is burned. Batteries. Wood has stored chemical energy. Candles have stored chemical energy. Can I move forward? Electrical energy. You do not have to write all of this. Basically, electrical energy is anything that has a plug and can be plugged in. It's energy that's produced by those electrical charges. So think about all the things that you know of that have electrical energy. Let's talk about the cell phone really quick. Okay? I plug it in at night, every night. While I sleep, it charges. So the electrical energy transfers its energy to the battery. And we know that batteries are chemical energy. Okay? And then that chemical energy is then transferred to light energy to make the screen turn on. It's transferred to sound energy so I can hear my phone calls or videos. If it stays on too long, it's transferred to thermal energy because it gets really hot. How many of you guys have been on your cell phone so long that it gets hot? Okay, so do you see the energy transformations just taking place in the example of the cell phone? Okay, good. Your next one is mechanical energy. Very, very similar to kinetic energy. When you think of mechanical energy, I want you kind of thinking like it's like a machine. You've got these moving parts. It's energy of matter because of its motion or position. Your examples, one of the examples on your test is that electric pencil sharpener. There's a piece inside of it that moves, that rotates to sharpen the pencil. You plug it in, so that would be an example of electrical to mechanical. You could also say electrical to kinetic because there is that movement. Another example would be your fan blades. Once again, you've got to plug that fan in, so that would be another example of electrical to mechanical. You've got moving water, which is an example of mechanical energy, which is especially true in hydroelectric dams, okay, when they release water to create electricity. Light energy is another type of energy. It's energy that is carried by electromagnetic waves via the visible light spectrum. So your examples are the sun, a microwave, a light bulb. Okay, if you're talking about some of these examples and how they fit into energy transfer, let's look at the microwave. Hopefully you're able to identify right now you have to plug the microwave in, so that's electrical energy that is then transferred to light energy from the bulb in the microwave, and then that light energy is then transferred to heat energy or thermal energy because it heats your food. Okay, your heated food is then has that chemical energy. When you eat that food, it's transferred to chemical energy. Are y'all seeing how the energy cannot be destroyed? It's just constantly being transferred. Hopefully you are. Okay, our last one is sound energy. Hopefully you're able to recognize some of this vocabulary from our last unit. So sound energy is energy that is created by mechanical longitudinal waves that transfer sound. And that's all I've got for you today. Thank you for taking Cornell notes. Have a great day.